Okay. Can I ask, please, everybody to take the front seats, please? Please take the front seats first. The front seats are prepared. They have some documentation and from the Atlantic Center, so please take the front rows. For those who are just arriving, can I please ask you to take the front rows? Tô. Não recebeste? Ok. Francisco, está toda a gente lá fora? Ainda há pessoas lá fora? Ok. Dear all, ladies and gentlemen, thank you very much. So, welcome back now to the working sessions of the 5th Maritime Security course of the Atlantic Center. For this afternoon, we have now our first panel entitled Mitigation, Prevention or Adaptation. What does science tell us? We have the pleasure to have Rear Admiral João Marreiros, which is the director of the Portuguese Hydrographic Institute, to moderate this session. Sir, thank you very much for accepting this invitation. We also have Professor Larissa from the Basso, from the University of São Paulo. Thank you very much. And Professor Tannecia Stephenson. Online, we have Professor Stefan Rahmstorf. I hope I pronounced your name correctly. Sir, it's unfortunately you cannot be present here, but we are very glad to have your participation online. So I will now hand over the floor to our moderator. Sir, thank you very much. Have a great panel.
Thank you. Good afternoon to all. I'd like to check that everyone is listening in good conditions. Stefan, are you listening me?
Yes, I can hear you well.
So we can proceed. Admiral Noronha Bragança, coordinator of the Atlantic Center. Thank you for this invitation. It's an honor being here to this course, to learn and to moderate this panel. Dear colleagues of the panel, Professora Larissa Basso, Professora Tannecia Stephenson, and Professor Stefan Rahmstorf. It's a pleasure to moderate your presentations during this panel. All attendants, all participants, ladies and gentlemen. This panel aims to present insights from climate science, highlighting how the data and research informs about the urgency, the effectiveness, and limitations from different approaches, how science can be used to inform policy priorities, and what trade-offs or synergies exist between different strategies in face of accelerating climate impacts. This is the initial class for this course, we can say that. This is the initial stage for this course. It starts with a presentation by each one of my colleagues, and I'd like to present each one of them. Professor Larissa Basso, research on commitment to sustainability transitions in emerging economies. She treats issues like engagement with climate change mitigation, actors' interaction in policy making, and how institutional frameworks affect the results are the issues that she's leading with. She has a law degree by the University of São Paulo, a master's in international law also by the University of São Paulo, and a master's in environmental policy by the University of Cambridge, and a PhD in international relations by the University of Brasilia. And she is a visiting scholar at the University of California and a postdoctoral fellow and senior lecturer at Stockholm University. Thank you, Professor Larissa. Professor Tannecia, how should I say your name?
Tannecia, but it is fine.
Tannecia Stephenson. He's co-director of the Climate Studies Group at Mona and senior lecturer and head of the Department of Physics at the University of West Indies, also in Mona campus in Jamaica. Her research interests are Caribbean climate variability, climate extremes, seasonal predictions using statistical models, statistical downscaling, and assessing comparative vulnerability using aggregate indices. She has been affiliated with a number of climate variability and change projects, and she has published a number of journal articles and technical reports. Among them, she is the lead author of Chapter 10 of the Linking Global to Regional Climate Change for the Intergovernmental Panel on Climate Change 6th Assessment Report. Thank you, Professor.
Thank you, Director.
The other speaker is Professor Stefan Rahmstorf. She has a doctorate in oceanography at Victoria University of Wellington. Professor Rahmstorf came to Potsdam Institute of Climate Research via the New Zealand Oceanographic Institute and the Kiel Institute of Oceanography. Since 2000, he has held the professorship in physics of oceans in Potsdam. In his function, he presents his research results in the fields of paleoclimatology, as well as ocean circulation. He also offers online lectures including an e-learning program at the Virtual Academy for Sustainability at the University of Bremen. Thank you, Professor Stefan Rahmstorf. Now, after this brief presentation of all the speakers, I hand over right now to Professor Rahmstorf to deliver his presentation.
Yes, thank you very much for the introduction. I assume you can hear me well there.
I confirm.
Can you see my slides?
Yes.
Excellent. So I want to speak about ocean circulation change, and the background of that is something you probably all know, which is that we are in a period of rapid and profound climate change. We are already 1.3 degrees in global temperature above the pre-industrial level, and this warming was correctly predicted already decades ago because the energy budget of the Earth, the radiation budget, is well understood, and the role of CO2, the greenhouse effect, has been known for more than 200 years now, since 1824. And so what we see now is exactly what has been predicted, and it bears a number of risks, and one of them is the risk of major ocean circulation changes, and especially in the North Atlantic, the so-called AMOC, that stands for Atlantic Meridional Overturning Circulation. And that is shown in a schematic here on the right-hand side. It basically consists of a warm, relatively warm near-surface flow northward along the length of the Atlantic, coming from the Southern Ocean, actually. And then this current gives off a lot of heat to the atmosphere over the northern Atlantic, and the water thereby gets colder. It can sink down to between 2,000 and 3,000 meters depth because the colder water is dense enough to sink down. And then it flows as the blue deep current called North Atlantic deep water back to the south. And the amount of heat that this delivers to the northern Atlantic corresponds to 50 times the total energy use of humanity. So this is a huge amount of heat. It is sometimes confused, the AMOC, that is, with the Gulf Stream, which has this first historic map of the Gulf Stream by Benjamin Franklin from 1769. You see on the bottom there but that is because a part of the AMOC flow goes actually along the Gulf Stream, but it's actually the AMOC which delivers the heat, and the Gulf Stream itself, most of that returns near the surface towards the south in a horizontal gyre circulation, which is not shown on the diagram here, but it returns to the south at almost the same temperature as it flowed north. So the Gulf Stream itself doesn't deliver much heat, but the AMOC actually does. And there is a lot of indication from climate history that the AMOC has been quite unstable and has been the reason for some of the most dramatic and abrupt climate changes in the Earth history. And what is happening now, we can see here, if you look at the trend of sea surface temperature change since we have satellite data since 1993, you see that the northern Atlantic has cooled there. And in fact, we have, I think I'll show that later on, it has also cooled since the 19th century. That's the only part of the Earth that has cooled while the whole rest of the globe has warmed. And so I'm talking about this so-called cold blob, which is actually an indication of a slowing of this AMOC, which delivers less heat into this region. And so this is why this has actually cooled despite the increasing CO2 and other greenhouse gases in the atmosphere. There's also this region of excessive warming along the American coast, and that is also an indication of a slowing AMOC, because that is somewhat more complicated to explain because it is dynamics on a rotating Earth. But when the AMOC slows, this leads to the Gulf Stream shifting to the north, and that is what we are seeing here in this dark red patches, which have warmed a lot more than the average ocean surface. If we simulate the climate in a global climate model, then this is what the North Atlantic looks like. This is the model from NOAA in the Geophysical Fluid Dynamics Lab in Princeton, which has a very nice resolution of the ocean. And in red, you see the warm Gulf Stream as it flows north along Florida and then leaves the American coast at Cape Hatteras. And then it starts to meander there. This looks exactly like when you animate satellite sea surface temperature images, but it is entirely a model simulation that simply solves the basic equations of hydrodynamics on a rotating sphere. And with these climate models, we can make experiments. And if you look at an experiment where you double the CO2 content in the atmosphere, then you get this sea surface temperature change pattern. Now this uses slightly a different color scale where everything that has warmed less than average or cooled is blue, and everything that has warmed more than average, average over the globe that is shown in red. And now, so you see this cold blob region again, and you see that shift of the Gulf Stream towards the north. And in the model, of course, we have the full information that we can analyze, and so we know here it is due to a slowing of the AMOC in response to a CO2 increase in the atmosphere. Now in the observational data, the linear trend since the year 1870 looks like this. This was done by my PhD student Levke Cesar. We published that in Nature in 2018. You see very much the same pattern, except it's kind of a bit fuzzy because, of course, we don't have sea surface temperature observations at every spot in the oceans in every year since 1870. And so the picture is a bit blurry, but I think you can clearly see that what we call the fingerprint pattern of an AMOC slowdown, the blue part and the red part, in the observations. And when you calibrate this relative to the climate model, you conclude that this corresponds to about 15% weakening of the AMOC. And we can also see that in the satellite data. Now that's the same one that I showed you before, but now again, it's relative to the global mean sea surface temperature, so blue is not cooling but less warming than average or cooling. And here you see that shift in the Gulf Stream as well. So there's a very clear indication both in the long-term observations since the 19th century and in the satellite record that something quite dramatic is going on in the northern Atlantic here. There's also paleoclimate data, mainly from ocean sediments, which reconstruct the strength of that AMOC, because that leaves its traces in the sediments. And when you drill into these sediments, you can reconstruct the flow changes over more than 1,000 years. This is a compilation of different studies that have done that with different kind of so-called proxy data that indicate the past ocean circulation. And what these all have in common is that the AMOC looks stable over the last more than 1,000 years, and then it has declined dramatically to its weakest state since at least 1,000 years that has been reached in recent decades. This is of major concern because we know that the AMOC has a tipping point. This has been known since 1961, actually, when the famous American oceanographer Henry Stommel first recognized this in a very simple box model, which identifies the main feedback that leads to this tipping point. And basically what you see in this diagram is on the horizontal axis how much fresh water goes into the North Atlantic. Imagine meltwater from Greenland or increasing rainfall, and the strength of that AMOC on the vertical axis. And this is the possible equilibrium states. And because the basic equations for this are quadratic, you get a parabola that is lying on the side here. And so when you are, say, here on the present climate, but you add more meltwater, then you move along the right, towards the right here. And eventually, because this equilibrium curve bends back on itself, there is no more equilibrium with AMOC, and then you crash down here. And that is the famous AMOC tipping point, where we are pretty sure we are moving towards that, but we don't know how far away this is. This is a long-standing concern. As I said, I have been working on this since the early 1990s, actually since 1991, so for well over 30 years. And about 20 years ago, more than 20 years now, there was what was called the Pentagon report on this risk of an AMOC shutdown. That was called an abrupt climate change scenario and its implication for United States national security by some security advisors with the kind of title Imagining the Unthinkable. So it was a kind of worst case risk assessment. Here is some of an example of the worldwide media coverage that got at the time. In this case, yeah, I don't know which newspaper that was from, but of course the headline is vastly exaggerated, climate change will destroy us, but that just pointing out that this created quite a stir when this report became public. That was originally, it was an internal report for the Pentagon. And not long after, I don't think it's linked to this particular report, but not long after this famous movie, disaster movie, The Day After Tomorrow, came out in the cinemas, which of course is a Hollywood disaster movie. It is based on this AMOC crossing its tipping point, but a lot of the physics is not right in there. So, but this certainly made the topic of the risk of an AMOC shutdown quite popular for a while. Now, to jump forward to the current times, this is the kind of most recent study on this, which I am a co-author on, and it hasn't passed peer review yet, so this is only as a preprint right now, but it basically shows what the standard so-called CMIP6 climate models are doing in future global warming scenarios. So it's what these are the same models that you see in the last report of the IPCC, the sixth assessment report, except that in that IPCC report, the simulations stop in the year 2100. And so the IPCC reports the AMOC weakens a lot, but it doesn't fully collapse. But in this new paper, since the IPCC report, a number of these models by different international modeling groups have been continued beyond the year 2100. And this diagram shows all of those where the AMOC then ends up being collapsed. It doesn't collapse in all the models. In some, it recovers. But these are just the collapsed ones. In high emissions, these scenarios, these are the red ones, they're the high emission scenarios, SSP 585. Actually, all of them do collapse. So there are 9 out of these models that continue past 2100, and in all 9 high emissions scenario models, the AMOC ends up collapsed. For intermediate or low emissions, like the blue curve is a Paris-compatible scenario. Only in 2 of those, the AMOC collapses. And but so it means even with low emissions, if we stick to the Paris Agreement, we're not certain that the AMOC will recover. By the way, the observed trend, we have only measurements since 2004 in the Atlantic, direct observations of the AMOC. The observed trend is shown here. In itself, these measurements are too short to make a clear conclusion. What's happening to the AMOC? Is it internal variability? Is it a climate signal? But it actually is in line with what the climate models predict here. We also looked in more detail at the driving force of that AMOC, which is the deep convective mixing in the Northern Atlantic, which happens mainly in 3 regions, the Labrador Sea, the Erminger Sea, and the Nordic Seas. And to different extent in different models. These are 2 examples of such climate models. And the different color curves show the 3 different convection regions, the strength, the depth of that convection. So here it goes to about 1,000 to 1,500 meters deep, that deep mixing. But you see that the convection basically breaks down around the year 2050 in these models, or even a bit earlier. In this model, it would be breaking down around about now, actually. And we think this is the tipping point. Once that has happened, the AMOC basically will not recover. It will die. Now, note that this dashed scenario here, this is a low emission scenario, and in this model, the convection doesn't quite break down. It continues down to about 500 meters depth, and that is one of those scenarios where the AMOC does actually recover. But in the ones where the convection stops practically completely here, that's where the AMOC then dies down, although that doesn't happen suddenly, not in weeks like in the disaster movie, but it takes about 50 to 100 years to fully die. But the tipping point where we are set onto that path, and it will then happen by itself by internal feedbacks, even without further emissions, that is likely quite close. Within the next 20 or 30 years, we may well cross that tipping point. And that would be quite a disaster. There is this question, does deep convection already show a sign of weakening? Now, that is very difficult to measure. There are 4 different data sets which are shown here about deep convection since over the last 25, 30 years or so. And the data points year by year vary quite strongly depending on the weather. Some winters when it's very cold, you get very deep convection, other winters not so much. And the solid lines, they are kind of smoothing fits through these very noisy data, noisy because of the interannual variations. And so it's too early to draw a firm conclusion, but it is notable that in all these curves, they tend to go downward in the last 10 years or so. And so this could be internal variations, but it could be the beginning of that declining convection depth and approaching a tipping point. The impacts of an AMOC shutdown would be very severe. One example here is one of the actually very few existing studies that look at an AMOC shutdown in combination with a CO2-induced global warming. That's what you see here. And so you see a lot of orange, that is the global warming, but around the North Atlantic there is cooling despite the global warming. Especially affecting Great Britain, Scandinavia, and Iceland. And that is a typical fingerprint of the result of an AMOC shutdown, and that would really cause very serious problems for Europe. There are other problems with an AMOC shutdown, and that is this additional sea level rise of up to a meter or so around the North Atlantic. And with additional, I mean additional to the global mean sea level rise that comes from ice melt and thermal expansion. This is just a dynamic effect of the ocean circulation changing that also directly causes a sea level change. And around the North Atlantic, that is pretty well bad news. And the North American coast, Atlantic coast, is already a sea level rise hotspot. And there are substantial scientific literature studies on to what extent this hotspot of sea level rise along the US coastline is a result of that AMOC slowdown. Now, because this is such a big risk, 44 experts that work on this topic of AMOC shutdown have composed an open letter to the Nordic Council of Ministers that I had the honor to present at the Arctic Circle last October, which warns about this risk. And yeah, to conclude, many of the standard IPCC climate model runs are actually already on the way to collapse with the AMOC. The tipping point is probably in the next few decades, maybe already around about now. We can't rule that out. And the collapse risk is cannot be completely avoided according to what we know now from the models, but it can be greatly reduced if we stick to the Paris Agreement and really get down the emissions as fast as possible. And so we have no time to lose on this, and that is also the message of that open letter to the Nordic Council of Ministers that we presented last year. If you want to know more about this, there is this article that I wrote that summarizes the issue in more detail than I could present in my 15 minutes here. So thank you very much for listening.
Thank you, Professor Stefan Rahmstorf. You answered one of my questions to the panel already. It was a very good, very informative presentation. Now I give the floor to Professor Tannecia.
Thank you so much, Director. Director, is this the PowerPoint? Yeah. Colleagues, good afternoon. Thank you. Good afternoon, colleagues. Beautiful. Thank you to the organizers who have enabled my participation in this discussion. In this presentation, we're going to look at climate change in the Atlantic. Allow me to present the Caribbean perspective. We're still treating with the question, mitigation, prevention, or adaptation. What does the science say to us? There are a number of messages that we can get from the science. Allow me to set up a context first with respect to our Caribbean region. There's no shortage of science for our region. And so there are a number of publications and assessments that we can pull on. One you've heard about already is the Intergovernmental Panel on Climate Change. It has done a number of assessment reports. Some of the data, some of the information covers small islands and hence the Caribbean. We can also pull on what we call the state of the Caribbean climate, and that's the Caribbean doing an assessment of what we understand about our own climate science, what drives variability, what drives change, and what are some of the impacts that we're treating with. It also includes some indices that we are monitoring to help us appreciate the impact of climate change. And then there are some local studies available to us in the region. These in the middle are for Jamaica, where we did a vulnerability assessment for tourism, for water, for housing, for coastal infrastructure, and another sector, so that we have a better appreciation of climate change and its impact for us. Again, our theme in this discussion as a forum is, what is the science saying to us? And there are a number of messages emerging for the Caribbean, and I'll just summarize 2 of those messages. We're already at 1.1 degrees Celsius increase above pre-industrial, and when we look at our warming up to last year, we had reached about 1.3 since 1950, a trend since 1950. We're about at 1.3 degrees Celsius above pre-industrial. And the science is suggesting to us that we're heading for 2 degrees or more. In fact, one of the things coming out of the Intergovernmental Panel on Climate Change, when you hear me talk about IPCC, is that based on commitments up to about 2019, we're on our way to 3.2 degrees Celsius above pre-industrial warming. And so it points to the urgency and the need for us to mitigate, to cut our emissions. As we then read the science from a Caribbean lens, there are some contexts that frames for us. We love the outdoors. We have a number of natural resources we're dependent on. We're variations across our islands, some low-lying, some are mountainous, and we're small, largely isolated islands, but we do have countries on the mainland, for example, Belize and Suriname and Guyana in South America. With that as our context, colleagues, we want to suggest 3 insights from climate change science that we can extract from the science through a Caribbean lens. And we want to speak to, in this discussion, 3 implications for Caribbean life and what it means for us as a region. Therefore, colleagues, we want to highlight 3 things. Climate change, we want to suggest, is producing an era of multi-hazard unpredictability. Here's what we mean by that. Certainly for us in the region, like much of the globe, we're a lot hotter. This is a graph showing annual anomalies of temperature, surface temperature, and this has been averaged, over land and ocean for the Caribbean. And what it is suggesting is since 1950 onwards, we have been getting hotter, and for us in the Caribbean, like the globe, our hottest year was last year. When we look at our oceans as well, we see similar increases in temperatures. And so the dark orange is showing you areas where we are hotter, a lot hotter in comparison to other regions of the basin. And so when we look at our surface temperatures for our oceans, for the Caribbean Sea, we're seeing a rate of 0.1 to 0.4 degrees Celsius per decade. And we're seeing higher rates of warming over the Gulf of Mexico and over the Eastern Caribbean, extended into the Eastern Tropical Pacific. And so for us, every temperature index that we look at points to a warmer climate for us. Another thing we could look at, and this is just for Jamaica, on your y-axis, we are looking at January through to December, and we're following our years from 1961 outward to 2023, thereabouts. And what it is meant to show us, colleagues, is that that region of warmer temperature is expanding. And it's expanding even more in our latter years than we had in our former years. And so the science is showing us that we're going to be a hotter region with more hot days, 23 more, than earlier periods, and with longer summers, and a warming that is evident over land and over our seas. We can also look at our rainfall, and for rainfall, we see a lot more variability. It's not a smooth and pretty trend that we can identify, but what we see is greater variability, and you'll notice that in the latter part of that time series. You're looking at a annual rainfall time series. We're moving from 1950 out to 2024. The green heavier than normal, the brown, less rainfall than normal. And we see that greater variability towards the end. So when it comes to long-term trends, we don't see a significant long-term trend within our rainfall, but we see greater variability. And on the right, you'll see intense rainfall. So this is the R95 index. It's a measure of how much more rainfall we get in heavy rainfall events. And the blue is showing you areas where we have stations showing that we have more rainfall in these intense rain events than we had in the past. And the fact that it is a solid blue, it is showing you that the trend is statistically significant. You're still with me, ladies and gentlemen? Thank you so much. We're going to talk about more extremes. We have a lot more extreme events that we're contending with. We could talk about drought, and we have had 2 major droughts in recent periods, 2009 to 2010 and 2013 to 2016. Hurricanes would be important for us. We're in the hurricane belt, and something we see is that the share of major hurricanes over the Atlantic has been increasing, and that's shown in our plot on that right-hand side. The number of the most intense storms are on the rise, and that is shown. The gray shows us category 1 or 2. The orange shows us categories 3 to 5. Aim of the plot, colleagues, is to show us that we have more categories 3 to 5 we're contending with in the last couple of decades than we had previously. We can speak to higher sea levels. And so we could have shown a plot of the Caribbean Sea, and it would show that pretty much most of the Caribbean is registering higher sea levels. But what we show you today is a popular coast for Jamaica. It's Hellshire, and when you visit us, you'll eat some nice fried fish. But in the past, there would have been a shore for us to walk along. Right now, there is no more shoreline. The water is right up to where the shops are. And so for us, we can see the higher sea levels, and we can we experience these higher levels within our islands. If we want some numbers, 1.77 millimeters per year in the long term, and 3.5 millimeters per year since 1993. It's painting for us, colleagues, a picture of an emergence of multi-hazard climate era. Much like it is in your countries, it is for the Caribbean. And this is marked by unpredictability. And thinking about a beryl that turns up in a June at category 5, it's something that our science did not anticipate. Yes, we anticipated intensity, increased intensity, but we're just saying there's some emergence of the climate that we're seeing that we did not anticipate on. Hotter days, more heat waves, marine heat waves are a part of our record now, higher frequency of droughts, heavier rain events and flooding, more intense hurricanes, higher sea levels, and storm surge. And one of the outcomes, not quite your climate change, but one of the things we see emerging from a changing climate is increased ocean acidification. And one of the studies emerging is that we have lost 50% of our corals covering the reefs between 1970 to 2012. And some of this is also covered in the IPCC's latest reports that suggest that on the trajectory we're on, worst case, we could lose up to 90% and even more of our coral reefs. This is meant to show us, colleagues, impacts on us. So if we look at the types of natural disasters in the Caribbean, and we take out storms and floods, they're covering over 600 of the disasters we have seen between 2000 and 2023. And the plot on the right is just to show that the Caribbean is among those countries that are most vulnerable to these natural disasters, and that they've been coming at a high cost to the Caribbean more than to other states across the globe. It's good to see that on the maps, colleagues, but it's happening to us on the ground. When we start looking at the impact, 100 million for drought response is one of the headlines showing what's happening in our islands, and this is for Jamaica. We had to treat with a warmer Jamaica and what it meant for food shortages and how that reflected on the prices of the goods that were available. Or when we had a tropical cyclone 22 in 2023, We're supposed to be coming to the end of a hurricane season. And it's at a time now that when it hits us, it's causing $409 million worth of damage. At a time when you thought the worst has passed. So it leads for us more unplanned disruptions. It's changing the context within which Caribbean life occurs. This multi-hazard we want to suggest is a new normal for the Caribbean. And so with this as our context, allow me to show the last slide here. And the aim here is to show, it's not the last slide of the presentation, all right, colleagues? Don't get too happy. But the last slide of part 1 that is showing us year by year some of the events that the Caribbean is contending with. This one is for Jamaica. So we get hit in 2000 with a drought, and then 2001 with a hurricane, followed by flood rains in 2002. You get a break in 2003, then to make up for that, you get hit twice in 2004. This is the reality of our governments, and trying to recover from these is a challenge. Something that the table is also showing for us is a cost for GDP. Something that my colleague has also put in, Michael Taylor, is something that we haven't even begun to assess for our region. What's the impact of the heat? Our temperatures are rising, and that has an impact for health, an impact for agriculture, an impact for water availability, and we haven't begun to quantify that impact as yet. Let me move us then, colleagues. So we have this multi-hazard unpredictability that we're treating with. It's leading to a lot of unplanned disruptions, and those development goals we have nationally and regionally, and I want to suggest globally, are being interrupted. Allow me then to move to part 2, colleagues, where we have, it's an era we want to suggest where multi-sector goals are being undermined. What we mean by that? Climate change will continue, and here's what it looks like for the Caribbean region. We, in worst case scenario, may be as warm as 4 degrees by end of century, worst case. And if you look over our seas are warming, and our land is warming, land much faster than ocean in these scenarios. And the days are approaching where we can characterize most of our days as being hot by the 2090s. When we look at water availability or rainfall, we're looking and anticipating a dry Caribbean, especially in the summer. And this would have been the time we would have normally had rainfall to take us through the climatological, the normally drier periods of the year. So if we get drier earlier than we have anticipated, it has implications for water availability. And so we still have that variability, but the science is suggesting that we're going to be drier. We're going to have more intense, so the intensity of our droughts will increase. We'll have more intense droughts that we have to treat with. Storms would be intenser with higher rainfall rates and stronger winds is what the science suggests to us, and even higher sea levels to contend with. Previously, it was thought to up to 1 meter, but the science is suggesting that we may have underestimated some of the dynamics at work, and we may very well be above 1 meter. The table then, colleagues, is a summary of some of the different areas that we have to treat with as a Caribbean region. Hotter, more variable rainfall, but tending towards drier. More intense storms coming through, dealing with your sea levels, your coastal floods, your coastal erosion, marine heat waves, and increased ocean acidity. And so as we look at the future, it is suggesting to us as a region that we're going to have an entrenchment in this unpredictable, multi-hazard kind of environment, and it's going to be marked by unprecedented climate change in the future, and we have already spoken to many of the changes, some of the changes that we anticipate in the future. We're anticipating more unprecedented climate change, but we want to also suggest in this discussion that we're already seeing unprecedented. When we have Katia, Irma, and Jose in 2017, Dorian in 2019, 30 named storms in 2020, Beryl, who was a storm in and of itself in 2024. The Caribbean, like many other locations in the globe, is already experiencing unprecedented climate and is already experiencing unprecedented climate change. It undermines, we want to suggest, every sector of Caribbean life, whether it is the heat stress that our farmers treat with, or beaches disappearing because of sea level rise, or treating with agriculture, any area of Caribbean life we want to suggest is being touched by a change in climate. And what it means for us is those goals we have set nationally, globally, are becoming, it's escaping us as our climate changes. So we have more unreliable determinants of quality of life as we move forward. Globally, we have the SDGs. Nationally, we have something we call Vision 2030 in Jamaica. And so let me wrap up this part of the presentation. Each sector is being impacted, and those development goals that we have set for ourselves are being delayed. Last part of the presentation then, colleagues. The press release coming out of IPCC calls for urgent climate action and that it can secure a livable future. And so what we have already been seeing and what is projected for the future says to us there's immense urgency for us to be responding. And on screen is a quote that comes from the Prime Minister of Barbados, PM Mia Mottley, who says, boy, the problem of our temperature is that our temperatures are changing faster than we had anticipated, or that we're making changes to treat with. And so we have a bigger problem than we had anticipated. And that is true when we look at the impacts for the region. Colleagues, as a region and with other small islands, we have argued for 1.5 to stay alive. That Paris Agreement. Let's constrain the warming to within 1.5 or less and no greater than 2 degrees. But sometimes what we fail to see is for small islands, 1.5 is not an ideal world. It's really a compromise on what is happening globally. At 1.5, it's 40% less hydropower in Suriname. We have regional damages from hurricanes to contend with. We have diminished agricultural productivity. And we have coastal inundation of some of our seaports. So even at 1.5, colleagues, the Caribbean remains vulnerable and at risk to a number of climate impacts. And we have already spoken to 2024 being the warmest on record and being the first year that we have recorded 1.5 degrees. We're not suggesting that we will stay there, but we now have a calendar year that shows that sets precedent of a 1.5 above pre-industrial. And so, colleagues, our options, the climate development options are now demands. We're running out of options where we want to suggest in this discussion. And now we have to be acting urgently. So the climate is changing the context within which Caribbean life is happening, and so more of the decisions now are unavoidable. It brings us to adaptation, and it's one of the things we're going to treat with, mitigation or adaptation. And for us in the Caribbean, it's both, but a lot more adaptation because we're already feeling impacts, and we have to treat with a worsening of impacts. And so every sector within our region is evaluating, I believe, how it's impacted by climate change and what it will take to sustain Caribbean existence under any one of these sectors. But as a region, we also appreciate that mitigation is crucial because we have to go back to the source of the problem, your greenhouse gas emissions. And though we're responsible for 0.1% of the emissions as at 2019, I think the region is also committed to cutting its greenhouse gas emissions because there are win-wins for our sustainability, especially in being less dependent on greenhouse gas emissions. And so for us, any number of areas become important: waste management, transportation, and a lot more effort now is being looked at electric mobility and what opportunities are there for the region. Energy demand management, renewable energy, energy efficient technologies, all of these contend within the region as we try to look at a way to respond. I'm wrapping up, colleagues, I'm almost at the end. And so for us, we are prioritizing data collection because important for us is not just the climate change data, but impacts data. We have to better understand what are the impacts of climate change. And we have to be able to quantify it, especially as I believe as a region we try to tap into the loss and damage mechanisms. And so we need that data to help us, I think, with attribution studies, and so to position us to be able to target some of the financing that will help us with response. Innovations and technologies fit for purpose within the region become important for us. Early warning systems become important for us, and advocacy and new models around governance becomes important for us. And so we think, yes, adaptation, mitigation, but having a populace that understands and can appreciate the linkages between what they see on the ground with agricultural yield, for example, and diminished yield, and climate change becomes more important. And even our young people understanding climate change becomes important. And so treated with education programs at different levels become important to us. Collaborations and financing colleagues becomes crucial to small islands as we try to respond to our changing climate. All of these we want to suggest, colleagues, is important for the region as we advance sustainable development for all. So in closing then, colleagues, we have seen multi-hazards, we have multi-sector impacts we're treating with, and so we want to suggest that the urgency is multiplied and that development demands that as a globe and as a region, we make some urgent responses in the face of a changing climate. Takeaways: ignorance is no longer an option. Individualism, though it is on the rise, is no longer an option. Inaction is no longer an option. Thank you so much, colleagues. We look forward to discussions.
Thank you for your presentation.
Yes,
very
Director.
loud and clear.
Louder than clearer.
And very interesting.
Thank you,
We
Director.
start from the north with Professor Rahmstorf, now Jamaica, and moving south to Brazil with Professor Larissa.
Thank you very much. Can you hear me? Yeah? Okay. I can't hear myself very well, but well, I'm Larissa. I come from Brazil, and I'm going to try to make a different type of approach here. I'm going to go very quickly through some specific things that my colleagues already mentioned, but my idea here is to try to start to answer why we cannot solve this. We have all this data. We have all these models. We know what's happening. Why can't we reach an agreement and do something actually to solve the problem? So that's the idea. And the outline is this. I'm going to talk very briefly about the planetary boundaries, very briefly, and I'm going to explain why I need you to understand this. Then, they already mentioned a lot about the causes and consequences of climate change. I'm just going to divide in two. And I'm going to take time to go through the international climate negotiations. What have we reached so far? What have we agreed so far? And then, why the international domestic dynamics are actually the most important to answer the questions of why we can't solve anything. So, these are the planetary boundaries. I just want you to focus on this figure. I'm going to move to the later one just to show. Here, just focus on the different colors that you can see. You can see, like, this was the first paper published in 2009, and what we are looking for here, the more orange, yellow, the worse we are going through. So let's focus on the third one, which is the 2023. If we can use a metaphor, we can say that the planetary boundaries are like the systems that we have in the human body. Well, we have the respiratory system, circulatory system, you know, they interact, and we can do some changes and nothing happens to our health. Like when you have some fever, right? You can have some fever, and it's a little bit above, I don't know if you use Fahrenheit or Celsius, but a little bit above 36, 37. You just monitor that, and you see, okay, maybe we can go back to 36, 37, that's fine, go to 38. If it reaches some point, you have to go to the doctor, you have to go to the hospital, they have to do some intervention, right? So, why the fever? Well, you can have a problem in the liver, you can have a problem in the heart, it doesn't matter. But those things, they interact. The planet's the same. the scientists discovered that there are some systems, and so far we have identified 9, that they interact and we can cross some limits on concentration or types of ingredients, if you can say, that can be there. And then if they stay within these limits, we can go back to healthy. What are those systems? Just very briefly, these papers are open access, you can access. Climate change is one of them. So the concentrations of greenhouse gases in the atmosphere is one. Not only in the atmosphere, also in the oceans. But anyway, this is just one. The other ones, just to mention, the ozone layer, the biochemical flows. You have nitrogen and phosphorus that we add to have more outputs in agriculture. So those are the systems. When you change a little bit in one, you are going to have consequences in the others. And what is really worrying here, if we stay within the green, we are fine. We are within those limits that we go to the doctor, they say, you take that, you're going to be fine. If you're up above the green to the orange and yellow, then we are in danger. So you can see that, and remember I showed you the figures, this is getting worse. What are the consequences of, so first the causes of climate change, this is just to mention. We are having higher concentration of greenhouse gases in the atmospheres. You can see this, and this is increasing in the daily basis. So this is like the main cause. This is very complex, but we can simplify like that. What are the consequences? First, this is a graph. There was a paper. This is available in YouTube too. One is the average increase in temperature in the long run. So this is like one of the consequences of climate change. Oh, but in my country had a severe winter last year. Yeah, of course. You can have variations. But in the long run, when you use the models that, for example, Professor Rahmstorf just showed, you can see that you have more of those red, yellow, and red dots for every year that we advance, and this research is only up to 2017, compared to what we had before. So in the long run, the average temperature of the planet is increasing. And the second consequence is this. The extreme weather events that Professor Stephenson mentioned for Caribbean, we have in Brazil, I'm sure you have in all your countries. This is becoming stronger and much more frequent every day. So what happens is that scientists now, we are observing this, and when the body goes through these changes and we don't know, for example, the temperature is too high, you actually don't know what can happen. That's the same with the planet. We don't know, like in the long run, a lot of things can happen, like the circulation of the Atlantic Ocean. It's already been there, and a lot of other things. So now I go to my part, the part that I am a specialist. What have you been trying to do to solve this? So the international climate negotiations, they started in 1992. The convention, the founding convention of climate change, which is the United Nations Framework Convention on Climate Change, was signed in Rio, actually in Brazil. And what did the countries agree at that point? It's very common that for environmental regimes, you have a founding treaty, and then you have meetings to negotiate every piece of it, because it's very hard to reach an agreement at first. And even like the science always getting better, you need to have more negotiations for what you have agreed or you have discovered. So by then, in 92, the members of the United Nations, they agreed to stabilize, so they're going to reach an agreement to stabilize the concentrations of greenhouse gases in the atmospheres in levels that would prevent dangerous anthropogenic interference with the climate system. Well, we failed. That's it, let's go home. That didn't happen because the consequences are already there, okay? But anyway, let's go back here and say, okay, so that was the agreement. That, and of course there are many things, but the second thing that I want to mention is this. In the same convention, we have this principle of common but differentiated responsibilities. What does that mean? And why is this relevant? At that point, you had, and I'm going to show you later, some figures showing that some countries putting together, they had much higher emissions than all the other countries combined. And those countries that were put together, they were considered the ones that were industrialized before, they were put into this Annex 1. So those countries, they would have, okay, you need to do something first. Do we already have an agreement on what do they have to do? No. This was just like dividing the countries because at that point it made sense. It doesn't anymore, and I'm going to show you why. But at that point it made sense. So, okay, what were the outputs of this convention? These are the main ones, okay? So we agreed to stabilize the emissions, to actually the concentration, and we put countries in 2 different groups. Then they decided too that we are going to meet regularly, and in the case of climate change, that means early, every year since '95, which was the first COP, we would meet to try to reach an agreement of what should we do, who has to do something, and when. And the first agreement was in Kyoto in '97, and what was agreed was that the countries that were put on that list, they would have to reduce their emissions starting in 2008 until 2012 by 5% below 1990 levels, okay? So you take your emissions in 1990, you have the accountancy that's there, and you say, okay, between 2008 and 12, you need to reduce by 5%. That was the agreement. So it was only for the countries that were in Annex 1. That actually didn't work very well for many reasons. I don't have time to go into the real politics of it, but like starting in 2001, the US withdrew from the Kyoto Protocol, so it was no longer a member. The US, they had the highest emissions at that point, so if they are out, well, that means that this is not effective. Remember, always remember the objective. The objective is to stabilize the concentrations. If the US is not there, you cannot stabilize, right? Also, something else happened, and I'm going to show later. Emerging economies, mainly China, of course Brazil too, South Africa, and some other ones, but China and India, they had a lot of impact. They were emerging. So if they were emerging, they have more and more emissions too. So if your objective is to stabilize, you need to get these people on board, otherwise this is not going to be stable. So by 2009-10, the negotiators, they were already thinking about how we're going to replace the Kyoto Protocol, because this didn't work. This is not going to work in the long run. We need a different model. So this top-down, which means, okay, everybody 5%, it doesn't make sense, because some countries, they don't even contribute that much to the emissions, and some countries, they need to reduce more than 5%. So these top-downs, the same for everybody, doesn't work. And there's also a disagreement about historical emissions, which was the basis for dividing the countries into Annex 1 and non-Annex 1. And I'm going to show you that it actually makes sense. So this is to show the graph that I promised. The orange line is the non-Annex 1 countries. The Annex 1 is in orange and non-Annex 1 is in blue. They are in blue. So just these two. I didn't separate China in purpose because in the convention it's not, but yes, anticipating one of your questions, China has a lot to do with this. But in 92, see the first arrow, 92, see the difference between the Annex 1 countries, they actually had a lot of the emissions, so it made sense to tell them, you have to do something before. Then 97, which is the second arrow, it's getting closer, but it still made sense. So it's not valid, the argument, oh, the Kyoto Protocol, that was like bound to fail from the beginning. No, it made a sense at that point. We always have to understand the decisions from the circumstances that they were taken. So there was a point. But in 2003-4, more or less, China becomes the biggest, the greatest emitter of greenhouse gases. And then when you move through the years until 2022, that's what we have more recent, the non-Annex 1 countries, they actually have more emissions than the Annex 1 together. So without going into other, which are very important arguments, even for countries like mine, Brazil, there is a point when people say, you need to get the emerging economies on board, otherwise we're not going to stabilize. So you need to find also a different type of model that could work to get more countries on board. And for the argument of historical emissions, which are the emissions since the industrialized, starting of the Industrial Revolution. And that's mainly for countries like mine, Brazil, they always say, we have nothing to do with that, you know, because we didn't cause the problem. We don't have to actually do something right now. Not really. If you check the emissions that include land use, because there is a big difference. If you're only talking about burning fossil fuels, that's one thing. But other activities also put greenhouse gases in the atmosphere, for example, deforestation, for example, agriculture. There are many, many activities. And if you add those emissions and put all together, and here we have the data from 1850 until 2021, Brazil is the 4th biggest greenhouse gas contributor. So yes, we do have historical, even historical responsibility. So this is not to say that the argument is not valid. This is not to say that there are Brazilians that contributed less than other countries and we have difference within the country. Yes, it's all very complicated, but it doesn't help if you say, oh, we don't need to do anything, you know. You need to do something, also because you're very, very vulnerable. So, Paris Agreement, that was the model to replace the one that didn't work. What did we agree? So this was signed in 2015. It's in force since 2016. We agreed not only to stabilize, so we have a different objective now. We are talking about limiting the global increase in temperatures to 2 degrees Celsius until 2100, no, 2100, I don't know, 2100, that's it. Ideally 1.5, and Professor Tannecia already said that it's very important to keep within 1.5 for many, many countries. We also decided this top-down 5% for everybody doesn't work, so we're going to have nationally determined contributions. Every country should say what they are willing to do, and not only that, you're going to review it every 5 years to increase the ambition. So you say you can do something in 5 years, you should do a little bit more. So we can actually stay within these 1.5 degrees. And the negotiations that we continue to have every year are for implementation of this Paris Agreement. So we have a lot of subjects that we are negotiating. We are talking about monitoring and verification. So these biennial reports are the start of it. We're talking about how to make carbon markets more efficient. We're talking about financing and loss and damage. And because I know from my students that everything that I just talked here can be a little bit too theoretical, I have a video, short one, that I'm going to show you to summarize what I just said. So let's hope it works. Okay, so this is available on YouTube if you want to check. This is from a research institute in Oslo, in Norway. I think it was very good that they made this video. But now let's go through the point. What can we do and how can we understand? Okay, this is the negotiations. And in negotiations, the countries are there. So we want to understand, we came to this realization very early, but now because the ambition or the compromises or the pledges that the countries do, the countries say, it's not like 5% for everybody, it makes a lot of sense to understand what goes on inside the country, to say, why did Brazil promise that and not this? So if you want to understand the positions of the countries and how we can accelerate and actually do something about it, you actually need to understand national politics, national climate change politics. And I'm going to show one of the ways. I believe this way is very good, but of course, there are different ways of seeing this. So these are the emissions from Brazil from 1990 to 2022, and they are divided by sectors, okay? So the most important here is just to see everything that is in pink is land use, and then everything that is in yellow is energy, and orange agriculture. So what can we see from this picture? The bulk of emissions from Brazil actually comes from 3 sectors, not only energy, which is the major emitter for most countries that we study. In Brazil, actually, you have to look into 3 sectors. So if Brazil wants to be, you say, Brazil is committed to climate change mitigation. Well, you need action in 3 different sectors, not only energy. That's not going to take us very far. Brazil actually did reduce the emissions in a period from land use change. That was fighting deforestation in the Amazon. In the first 2 mandates of President Lula, that was very well done. And we are trying to continue with that. We had a little period in the recent years that it didn't work very well, but we are trying to recover. But actually, from the other 2 sectors, we didn't change much. Emissions are increasing. So you want to understand why this is happening in Brazil. You have to go through national politics and understand, in the land use sector, which are the actors, which are the groups, what are the benefits for them, for example, in keeping deforestation high or not having any policy on deforestation. Who is gaining? Who is not gaining, and which one is more powerful, and how they are voting for things in Congress. And the same is true for agriculture and energy. And just to give you another example, if you look into Portugal, I want to understand what happens in Portugal. Then you check Portuguese emissions, and then you can see that the yellow, which is energy, is much more relevant in compared to other sectors. So actually, if you want to fight or have an important, I know that the European Union has acts together, right, in the climate regime. But actually, when you implement the normative from the European Union, you implement in Portugal, you implement in Spain. So it makes sense to look into that. And then to say, why don't we have more, for example, I don't know, I'm not very an expert on Portugal, but more renewable energy. Well, you have to look into see in the Congress, in the Parliament, what are the interests in keeping fossil fuels high, for example, if this is the issue. We would have to go through that. Other sectors are important as well, yes, but if you have action in the other 4 sectors, and it could have more, but not in energy, that's not going to be enough for Portugal. So this is the model that I want to say. We have to look country by country, understand which type of interest we are dealing with in order to understand why the country doesn't advance, because for Brazil, it's very clear. Whatever we promise to do, we are already doing. And if you're not promising, it's because we have some entrenched interest inside the country, and you can see clearly in domestic politics that this is not getting approved. So just summing up, if we want to advance on climate action, we have to understand that climate change is not a traditional diplomatic issue in which, like, you're discussing a border, you're discussing, like, this is very traditional for RI studies. Oh, you're discussing the border, you put everybody on table, what are the interests, so forth. No, this is a changing issue. You need to look how this is going to be implemented domestically. So that's very, very important. And in the domestic politics sector, you have to look into the sectors that contribute most to the emissions of each country, and also consider, I don't have time to go through this, but This in research, in political science, we already know there is different. If you want to implement some type of legislation in democracy is one thing, in autocracies is another thing. Also, acceptance of climate change is higher in democracies. You have more people debating. Yes, it becomes harder, but you have more minds thinking too. So it's going to take longer, but you have more options that this is going to go through. And something that was already mentioned here, fragmentation and polarization don't help. Because whenever you put into different groups, you start to see the difference between different groups, but actually we are much more similar than we think. So actually putting people on table and trying to see what we have in common as, for example, developing and developed countries with all the difference that we have and we have to consider, with all the groups that need different things that we have to consider, but actually it's on benefit of us all to fight climate change. So just very briefly, that's what I had to present to you. Thank you very much for your attention.
Thank you. Very good presentation. This is the time we're supposed to finish, but we start half an hour later, so I have more 20 minutes at least. Okay. Okay. I have a lot of questions, but I prefer to give the floor to the participants. Please raise your hand if you have any question. Please, we have one question here. Microphone. Here.
Yeah, my name is Tanto. I'm from the Port Management Association of West and Central Africa. I'm the projects manager. I'd want to ask a question to a professor who is joining us online. I'd want to know when did we pass that point where we irreversibly will be moving towards the collapse of AMOC? Can we identify that point in time when that happened?
It hasn't happened yet, but as I tried to explain, it is looking like if we continue with this high emissions trajectory, we will likely pass it within the next 20 or 30 years. Now, with low emissions, then we can reduce the probability greatly that this will happen, but even that wouldn't save us for sure.
Mm-hmm. Okay. Thank you. Professor Rahmstorf, concerning with your presentation, we know that the Earth's climate is changing through history. The last million years, there have been, I think, 8 cycles of ice ages and warmer periods. The last ice age was about 11,000 years ago. Is it possible that the current warming may be due to another reason, like orbital dynamics, such as precession, eccentricity, or obliquity of the Earth, rather than human causes?
No, that's not possible. We understand these ice ages very well. I hope everyone learned the causes in school because they have been understood since the 1920s, so also about 100 years. I certainly in the 70s, when I was in school, I learned the Earth orbital cycles in geography lesson. And by now, the climate model that we are running in my department can reproduce all the beginnings and ends of the last ice ages of the last 3 million years, driven only by these orbital cycles. And that's why we are also pretty confident that the next ice age would be due in 50,000 years from now, except that our emissions probably have already prevented it, because even in 50,000 years, even if we stop emitting now, the CO2 that we have already added to the atmosphere is enough to prevent the next ice age from these orbital cycles. Our CO2 concentration is already higher than any time in the last 15 million years now. Another reason, of course, why we know it's not caused by orbital cycles, the warming, is because the orbital cycles, if anything, they would tend to slight cooling. But the shortest of these cycles is 23,000 years long. And the changes, like the change from the last ice age into the Holocene, that was 10 times slower than the warming that we are causing now with our greenhouse gas emissions. So our human-caused warming is just an order of magnitude faster than these natural orbital cycles.
Thank you for clarifying that, because some people don't believe that it's mainly due by humans.
Well, they need to read the IPCC report, which concludes that 100% of the modern warming since the 19th century is human-caused. Solar activity is down, for example, if anything has counteracted slightly the human-caused warming. So there is no other no natural explanation for this warming, and it's unfolding exactly as it has already been predicted before it was even observed, global warming, predicted since the 1980s, the 1970s, quantitatively correctly.
There's a question there.
Okay, please.
Ricardo Tavares da Costa, European Commission. Thank you, first of all, for the presentations. They were amazing. I want to start by saying this, and I think you've been following the negotiations and the diplomatic efforts. How do you bring in states which their economies depend on fossil fuels? That's a tricky one. How do you convince them? And then second, I want to give also this perspective, since we are in a maritime security course. Climate change is also a security issue. How do you tell a country to defend itself without fossil fuels? Thank you.
I think it's addressed to both of you.
You can have that.
I'm sorry, I don't know how to bring them on board. But what I can... Yeah, I know. Yeah, and I'm not saying that I have all the answers. Like, we are having this conversation right now in Brazil. Like, we are drilling a new, reserve that we just discovered. And actually, in Brazil, there are a lot of debate domestically that we actually don't need, because at the time that some people say, no, we absolutely need it. But for the time that we are going to start drilling, it's going to be longer, like in 15 years, and then God knows what's going to happen. Maybe there's not going to be need of oil. So imagine the countries that depend, like their economies depend on that. What I can say is this. I truly believe that it's, and then of course for example, I don't know, Saudi Arabia, they're going to have, in the short term, they're going to have to diversify, they're going to have to do something different than countries that don't depend on fossil fuels, absolutely. But in the long run, everybody's going to suffer from climate change. So I think we're going to have to make, like, when you talk about getting people on board, you have to present that it's on their interest as well to get on board. Of course, it's going to be more difficult for some countries than others. And in the Paris Agreement, in the annual negotiations, we are talking about also how to compensate. Yes, that might be like a bad word, compensations, but maybe that's a type of action that you could take. You could bring different, Saudi Arabia is investing highly in solar energy right now. So they're, in a way, trying to diversify. So I don't have the answer, because I would have to study a country in particular to understand how the interests work there and try to get those people on board. But for sure, I can say that it's unlike in overall, there is an interest of like at least reducing climate change for everybody, because everybody's going to suffer. And what we already know is there are a lot of things that we don't know yet, because things are changing so quickly that we have to keep up with science. And probably it could be even more complicated in the future. So doing something now will cost less than do something in the future, for sure. But yes, you're absolutely sure, right. This is not easy. Island states, same thing. Like they're going to disappear. You're going to talk to Tuvalu, for example. They're talking about, should we move our state to Australia? Who's going to like give us a piece of? Because in, I don't know, 15 years we don't exist anymore, and it's like really a tragedy if you think about that. So I think we should think more collectively, and I think it's very hard in times in which you're talking about fragmentation and the return of geopolitics, but that's the situation that we have. And I truly believe that if we created this problem, we can solve it, but not with the same mindset. We have to change our mindset, then maybe we can find a solution. But sorry that I don't have like a clear answer for this right now.
Do you want to add something?
No, the dilemma exists in CARICOM. We have Guyana who has found oil, and Guyana is not going to use the oil they have found. And what can you say to a country who is developing? It's a hard decision, a hard sell.
And Professor Rahmstorf, do you want to add something?
Sorry, I also don't have the answer to this very tough question.
I have several. Can I give the word to the coordinator of the Atlantic Center, please?
Can you hear me? Yes.
But not Professor.
Thank you very much to the whole panel, and I think it was a very clever decision to start with science in this discussion, and because I think we need to hear the science regarding this. But as science, and we already talk about balance and all that situation that arrive for developing countries and so on, but tell me, as scientists, what was the results of the pandemic period regarding this? What was the impact that the world slowed down a little bit? What was the impact on this? There are already some figures, some conclusions, some ideas. Thank you very much.
No problem, sir. Please. So we got cooler for that period that we slowed down. And then activities ramped up, and the temperature shot up again. So it wasn't a sustained cooling that we saw, but we did see the effect of things slowing down, and we did see some cooler temperatures in that period.
Yes.
I think he had
Oh, man.
Okay, please, sir.
Working. Can you hear me correctly?
We can.
Cool. Thank you. My name is David Willimer from the Institute for Security Studies. Thank you as well. Brilliant presentations. I just wanted to probe Prof. Basso, if I'm pronouncing that correctly, a bit further. Given the urgency that has been highlighted and emphasized this afternoon, would you say the multilateral system as it is it working? And secondly, what lessons, and not being controversial here, what lessons can we learn from the Kyoto Protocol withdrawal by the US that can perhaps inform us in this moment with the Paris Agreement withdrawal, because the world does have to move on, for sure. Thank you.
So I'm going to start with the last one, and then I'll move to the first. So lessons from the Kyoto Protocol. In international relations, international law, there is no police. Like, you can go after the Bush administration or Trump and say, you have to do something. That doesn't work like that. We have to, like, the lessons I think we can take is countries can withdraw, and who else is there can keep doing the things, because one thing that we don't know is, of course, it's a tragedy when a big emitter withdraws, but if everybody else stays on board, it's lesser of a tragedy, you know? So at that point, for example, you had other countries still doing what they had to do. Did it have the impact that we imagined? No, but it did have an impact. So I think this type of feeling like, oh, they're not doing anything, so I'm not going to do either. What can you do as a country is up to you as a country, and you cannot force the other country to do. Second thing that I think it's important from Kyoto is, of course, the country negotiates as a country, but I think it was in the first panel that they mentioned, it happens a lot. In Brazil, it happens in many countries, and I know in the US too. Don't take what the Trump or the Basso administration does or do as the only thing that the US is going to do. If you look into different states in the US, they just kept doing climate policy. So California, the Northeast, and other states, they were implementing, and they start to implement even faster. The citizens, they look to what's happening in their lives, and then, you know, in 4 years' time, things can change. That's the beauty of democracy. Even though it doesn't work perfectly, that's the best we have, because it allows people to change their minds, and by looking into the results, just, you know, vote differently in the next time, or do different things in provinces, in states, and that can have a real impact. So I think this is the most important lesson. Of course, we are in a system that works within countries, and those are the countries that are negotiate in the multilateral system. But don't take for granted what can happen inside the countries. I think that's the main lesson that we have from Kyoto. And I think maybe it can help to answer also the other question, the first one that you mentioned. We are in a time that is very hard for multilateral negotiations, not only in climate, but if you think about trade, if you think about human rights, a lot of things, if we like those values, if we have those values, they are going kind of backwards right now. Again, yes, that might be hard now, but things can change, and they can change for the better. So I think also looking how Brazil goes with a big delegation, they take governors, and the governors sometimes they're really pressed by their citizens to do something. Maybe it works only in that state, but that could be huge. So even though it's hard, even though it's pressing, we are not going in the speed that we need, things can change. So if the US also is not going to participate this December, maybe China, you know, even though this is not a democracy, you do have some action happening there. And they are the biggest emitter. And God knows, maybe together with other big emitters like Brazil, the European Union, other countries, things can accelerate. And then in 2 years' time, things can change. So don't lose your hope. That's what I would tell you. Because as I tell my students, you know, generations change too. And new generations come with a different mindset. So doing everything we can, even though it looks very small, is everything you can. So that's very important. Don't lose hope because the other ones are not doing. Just keep doing, and you can build alliances with people and countries that you couldn't even imagine before.
One more question.
Yeah, perfect. Okay. Speaking of not losing hope, thank you so much for your insights. My name is Carolyn. I work as an advisor for the German Federal Foreign Office. So you can see I'm more from the security and policy side. So please, apologies if this is a rookie question. What I would like to know is if I imagine a very optimistic scenario. Let's say we somehow manage to, stop increasing temperature and to stop that everything gets even worse than it is already now, since we already suffer from consequences of climate change. Is there any research that is done, because we already have the consequences, will we just have to deal with them? Or is there any way that there is research, as you said already before, Professor, of course things change and there's a lot that we don't know yet, but is there an outlook that the consequences that we already suffer from it that will increase until we actually manage this point to stop things from getting worse, that we can go back? Thank you.
Maybe I address to Professor Rahmstorf.
Yeah, I could answer that, and at the same time correct the effect of the pandemic. The pandemic reduced the emissions by 5%, which in 1 year in 2020. In 21, it was already back at the 2019 level. And this has no discernible effect on the CO2 concentration, which keeps going up. And it will only stop doing that when we reach zero CO2 emissions, because the CO2 accumulates in the atmosphere. That's why the cumulative emissions since beginning of industrialization count for how much warming we get. And we will not get a cooling unless we start to actively remove CO2 from the atmosphere again. The problem is that this is very energy costly and also financially very costly. So theoretically, technically, it's possible. There is a plant on Iceland which already does that, but the amount that they reach with that is tiny. I have heard that just by the energy they need, they're actually adding more CO2 than they're removing with this so-called Climeworks factory in Iceland. But so there is experimental stuff in that direction, and of course by planting a hell of a lot of trees, you can also draw down some CO2. So there is some potential, but not very much, to actually actively start reducing the CO2 concentration, which would be required to actually get a cooling. But the IPCC has warned that what we are causing now will affect the climate for thousands of years to come, simply because the lifetime of CO2 in the atmosphere is actually tens of thousands of years.
And we have time for more questions. I don't think we have time for more questions. But no. Two quick questions. Okay, please.
My name is Ana Aguilar. I'm the lead climate negotiator for Panama. I'm also the residence advisor for my country. So I do both. I do the negotiations part, and I also do the practitioner part. And I actually wanted to echo what you said. I think one of the I know I'm not in the panel, but I really wanted to talk because it was really so on the maritime sector. So basically, the emissions from maritime sector and aviation are actually not even accounted in global emissions by country. That is very important because they're open, very briefly open negotiations to negotiate on them, but under the conviction or commitment of both sectors, aviation and maritime sector, to reduce their own emissions. And I think they are doing it somehow. So it is possible to move ships with just greener technologies, but the technologies are needed, and I know they have been developed because it's something that has been discussed. Aviation is a bit more complicated because of the type of fuel. Then I could stop here because I think you answered it perfectly, but just coming from my own country, I go with all fears and passion to those negotiations. I return to my country, very sad every time I finish those. But 10 years have passed since Paris agreements. There have been some efforts done. I mean, we have the loss and damage fund. That is something that was unthinkable. It was a taboo word 10 years ago before Paris. Now we have a lot of things. I'm part of the board. Then we have also the I don't know, we have all the NDCs. Actually, more countries are putting it there. We cannot lose hope on multilateralism, but we cannot stop working at government level. So that's basically what I wanted to add.
Okay.
Both things need to happen.
Thank you very much. We don't have more time, but you use what I want to say to finish this panel. Don't give up hope, and let's work together. Thank you very much. Round of applause to you.
Thank you.
Thank you very much for your presence here. So now we're going to a very short coffee break outside in the garden, and we will be back for the next panel. Senhor Almirante, aqui as placas.
Posso ler?